This is how you can test Malus's law, which describes how the intensity of polarized light passing through a polarizing filter varies as the filter is rotated, using just a couple of polarizing filters, in this case lenses taken from some polarizing sunglasses, and a mobile phone. But first, let's remind ourselves what Malus's law says. Malus's law describes the transmission of already polarized light through a polarizing filter. It doesn't matter whether that light was polarized at source or whether it was originally unpolarized and has already passed through another filter. What matters is how much of it is transmitted through this one. Let's suppose that the intensity of light arriving at this filter is I0 and the intensity which is transmitted through it is I. Now, I will depend on the relative directions of the transmission axis of the polarizing filter and the plane of polarization of the light. Now, let's give our polarizing filter a transmission axis which is vertical, like that. That means it will allow to pass through it any light which is polarized in the vertical direction, the vertical plane of polarization. But let's give our light a different plane of polarization. Let's say it's got a plane of polarization something like that, somewhere between horizontal and vertical. Now, it helps to remember that this here represents an electric field. It's a vector representing the electric field part of the electromagnetic wave. And like all vectors, it can be resolved into two perpendicular components. So let's have a look at that, and let's try redrawing our transmission axis down here, a little bit bigger so we can see it, and our polarization or electric field vector, something like that. Now, if we make theta the angle between them, then it should be quite clear to see that the component of that vector E0, which is parallel to the transmission axis, is E0 times the cosine of theta. So in other words, the electric field passing through would look something like that. Now, if you remember, the intensity of the light, or the energy in any oscillation, is actually proportional to the amplitude of that squared. Not the amplitude itself, but the amplitude squared, which means here I is going to be proportional to E0 squared times the cosine squared of theta. Now, Malus's law is actually normally written like this, with an I0 there instead of an E0 squared, because I0 is dependent on E0 squared. So this is Malus's law, and this is what we're going to check. Now, in order to test this, we need two polarizing filters and a means of measuring both the light transmitted through them and the angle between them. The filters I've got are just lenses taken from this pair of polarizing sunglasses, and I'm going to use an app on the mobile phone to measure the angle and the light intensity. Now, you must be sure that your lenses really are polarizing lenses. Not all sunglasses are, and the way to do that is to hold one in front of your mobile phone screen and check to see that the intensity varies as you rotate the lens, and it does. You can completely block out the light to get the lens in the right direction. So that's a polarizing filter. The app I'm going to use is called Physics Toolbox. That's it there. When it opens on GeForce, you will see that there's a menu at the top there. And first I'm going to show you the inclinometer, which will measure the angle. Now it's measuring in 3 dimensions here, and we're only really interested in how it's going to measure this kind of motion here. And that's the roll. You will see, if I can hold it steady enough at the top there, it should say 1 degree. And then if I move it that way or that way, it will go up to 90 or minus 90, depending which way I'm turning it. The light meter, it will give you a graphical reading, but you can click on digital reading there to get a number. And you will see that if I cover the sensor, it drops right down. And if I use a filter, I can drop the light right down as well. Now, what we're actually going to use on here is multi-record, because that will allow us to record both the light data and the inclinometer data together. So that will allow us to keep a record and output that data at the end. One thing you might want to be aware of is that if you're using an iPhone or an iPad, that light meter might not be available as an option. And that's because Apple blocks its light sensor from being used by some apps. You might be able to find something equivalent that will do the same job on the Apple Store, or you could just borrow an Android. So if I press plus now, that will start to record, and it's recording both the angles and the light intensity that's passing through. And what I'm going to need to do is to now fasten one of these filters over the light sensor there. So I've just got a little bit of tape, and I'm going to fasten this on. It looks fairly crude, but it does work. So my phone is now wearing part of a pair of sunglasses, and the other one I'm going to hold against it. So the idea is I'm going to hold these together and then rotate one round like that. Now, it's quite fiddly to do because you need to keep them both steady, and you need to make sure that your fingers that are holding this one are not actually getting in the way of the light. So I actually found it easier to fasten that one to the window with a bit of tape, and then I could concentrate on holding the other one steady as I rotated it. So let's just try that very quickly now. Starting from now and rotating 90 degrees, and then rotating back again 90 degrees. Now, when I stop this, you will see it gives me the option to save a file, and then you can export that data and you can import it back into a spreadsheet to process it. A word of warning, that data is exported as what's called a comma separated file, a .csv file. And the comma is taken to separate two individual pieces of data. So check the language settings on your phone first, because if you're using a language or regional setting which uses a comma as a decimal point, that's going to be interpreted as a break in data rather than a decimal point. You can sort it out in the spreadsheet later, but it's far simpler to just export it in the right format first. So check that your phone is actually going to export it with a dot for a decimal point instead of a comma first. You can upload it to Google Drive, you can email it to yourself, whatever you want to do, and then we're going to import it into a spreadsheet and see what it looks like.